So we are talking about word problems that have to do with systems of equations. So we could graph them, we could substitute, we could solve using elimination. They're just going to be, instead of them giving us two equations, they're going to give us a real life situation. We're going to have to write the equations and then solve. So when we are given a word problem, the first thing we want to do is just read the word problem and kind of get an idea of what's going on. So I think the hardest thing about a word problem in math is we're so used to getting a problem and just diving right in and starting to solve as soon as we see it because it's giving us an equation asking us to solve, or it's giving us a system asking us to solve. As soon as we look at it, we know what we're supposed to do. But with word problems, there's a little bit more to it. So the first thing we want to make sure we do is read the problem. We want to read the problem, we want to get an idea of what we are going to be looking for. So we want to know, are they asking us about ticket sales? Are they asking us about apples? Are they talking about school buses? Like, what's going on in the problem? What are they talking about? So we just want to read the problem and kind of get a feel for the situation. So after we read the problem, then we're going to go back and read it again and pick out our two variables. So there will always be two things that we're going to be talking about in these equations, just like we saw in the Do Now. There was the drama club and the art club. There's always going to be two things or two variables that we can pick out. So read the problem again and pick out the two variables. Now, when you're picking out the variables, you can always use x and y. If, like when we were solving them, we normally saw x and y in our equations, we're comfortable using x and y. Or you can really use any letter you want. So personally, I like to go in and pick letters that kind of go with what I'm talking about, so that when I'm solving it, I remember, oh, D was the drama club. Oh, A was the art club. Instead of having to remember, oh, did I make drama club X or did I make drama club Y? So we're going to pick letters that kind of go with it. And when we pick out the variables, we want to make sure we're super, super specific about what we're calling the variable, because the more specific we are, the easier it'll be for us to write an equation. So we want to make sure we are very specific. So we want to say things like D is the number of students in the drama club, or A is the amount of money we paid for the apple. We want to be really, really specific with what we're actually measuring so that when we go to write the equations, it's easier for us to write the equations. We don't want to just say, oh, D, drama club. We want to say what we're counting in the drama club. So then once we do that, we're going to write equations. We're going to solve the system. And then we're going to go back, read the question again, and make sure we actually answer what the question is asking. So after we solve, we want to make sure we answer the question in the word pattern. So sometimes maybe they're going to just ask us for how many students were in the drama club. So we're not going to need to know both things. Or they're going to ask us how much money we spent on bananas, and we'll just need the answer for that. So we want to make sure we're answering the question that's actually being asked, not just giving them a bunch of information because we solved the system and these were the answers we got. So we want to make sure our solutions actually answer the question. So let's look at one together. And actually follow the steps that we just wrote down. So when we're solving a question like this, the first thing you want to do is just read it. Read it to get an idea of what's happening. So a company that offers tubing trips down a river rents tubes for a person for $20 and cooler tubes for food for $12.50. A group spends $270 to rent 15 tubes. How many of each tube does the group rent? So now we know they're talking about a river rafting company. We know we're talking about some kind of tubes that you can rent. So now that we kind of have an idea of what's going on, now we want to go back, read it again, and pick out two different variables, two different things that they're talking about. So we know they're talking about tubes. We know they're talking about river rafting. So we want to find something that they're talking about two different types of. So when I go back and read it again, I see a company that offers tubing trips down a river rents tubes for a person and for a cooler. So right off the bat, I see, okay, person for 20 and cooler tubes for $12.50. Then they're telling me that a group spends $270 to rent 15 tubes, which is going to help me write my equations. And they want to know how many of each type of tube does the group rent. Almost every single time, that very last question will tell you exactly what your variables should be. So they want to know how much does each tube cost. So that tells me I need to know how much the person tubes cost and how much the cooler tubes cost. So that means I'm going to use my variables will be P and C. Now I don't want to just say P for person tubes and C for cooler tubes. I want to be super specific. So I'm going to go back and read that question again that they asked me at the very end. And they say, how many of each type of tube does the group rent? So they don't want to know how much the tubes cost. They want to know how many tubes they're getting. So when I label P and C, I'm going to label P as the number of person tubes being rented and C as the number of cooler tubes being rented because they're asking me to find how many they're renting. So I want to make sure what I label my variables actually has to do with the question that they're asking. So I'm going to say P equals the number of person tubes being rented, and C is going to be the number of cooler tubes being rented. So that means once I find P and once I find C, I'll actually have my answers to the question because I'll know how many of each tube I rented. So my next step, this is the trickiest one. This is where I have to write two equations because I have two variables. So I know I need a systems of equations in order to solve it. So I'm going to go back and I'm going to say, okay, they told me A group spends $270 to rent 15 tubes. So if you counted up all the tubes that they rented, they have a total of 15 tubes. So if I took my person tubes and my cooler tubes, I'm going to get 15 tubes. So that tells me that my first equation is going to be P plus C, right? The number of person tubes plus the number of cooler tubes equals 15. But then they also told me that they spent $270. So for every person tube that they bought, it cost them $20. So that tells me that I'm going to have 20 times P would give me the number or the total cost for my total number of person tubes, plus 1250 C, because that would be my total cost of cooler tubes, equals the total amount that they spent, that $270. Writing the two equations, I think, is the hardest part. Once I write the two equations, now it's really up to me. Do I want to use elimination? Do I want to use substitution? I'm probably not going to use graphing in this situation because I already see that my P and my C are both on the same side of the equal sign. I have like a 1250 of dealing with decimals, so it's probably not great for me to graph these. So I'm going to take graphing off the table. But I could use substitution or I could use elimination. Do you have a preference? No? Okay. So when I look at it, personally I prefer to use elimination, but in order for me to use elimination, I'm going to either have to multiply the top equation by 20 or 1250, which is not so great. Or I can rewrite and substitute. So I'm going to decide, let's see, if I'm going to solve this, I'm going to multiply this top equation by negative 20. Because even though negative 20 is a big number, it's really only like I'm multiplying each thing by 2 and adding the 0 on, so it's not too much for me to work with there. So if I multiply that top equation by negative 20, I end up with negative 20p minus 20c equals negative 20 times 15 gives me negative 300. And then I'm just going to rewrite my bottom equation because I'm not changing that at all. So I have 20p plus 1250c equals 270. And now my equations are set up for me to solve by elimination. So I can go in and I can say, okay, let's add these together, which will cancel out my p's. Negative 20 plus 1250 gives me negative 750c, which equals negative 300 plus 270 gives me negative 30. Now I've got to get rid of that negative 750. So I'm going to divide on both sides. When I do 30 divided by 7.5, I get 4. So C equals 4. Am I done? Did I answer the whole question? No. I know that I bought 4 coolers, right? 4 cooler tubes, but I still need to know how many person tubes I bought. So I'm going to go back. I'm going to take that first equation because the one before I multiplied by negative 20, the P plus C equals 15 to solve for P because that's my easiest equation to work with. So I take P plus C equals 15, and now I know that C is 4. So I really have P plus 4 equals 15. And then in order to get P all by itself, I just have to subtract 4 on both sides. So I get P equals 11. So I bought 11 person tubes and 4 cooler tubes. So I could say for my final answer, I have 11 person tubes and 4 cooler tubes. The trickiest part is getting those 2 equations. But in your classwork, it's going to walk us through step by step. It's going to have us pick out the variables and check that we picked the right variables. Then it's going to have us write the equations and check that we wrote the right equations before we go to solve so that we can make sure that we're writing those actual equations correctly before we start to solve and make you a little bit more confident in your ability to do this because you guys got this. Do you want to see another example or do you want to start working on the classwork together? Do the classwork? Okay.